the previous video, we have discussed and demonstrated the solution for analog input processing. This analog input processing is demonstrated using calculate instruction, normalize instruction, and scale instruction. These three instructions can only be used for S7 1200 PLC and S7 1500 PLC. I'm going to show you and demonstrate to you analog value processing, especially for analog input S7 300 PLC or S7 400 PLC. For S7 300 and S7 400 PLC, we're going to use the function block FC105 for scaling values and FC106 for unscaling values. For this demonstration, I'm using a PLC S7 300 CPU and analog input card 12-bit analog input. We're going to create our ladder logic programming in the OB1. FC105 is located at basic instruction and then conversion operations. Then we have scale and unscale. Scale is FC105 and unscale is FC106. So drag and drop scale into our network 1. There are few terminals for scaling function. We have enable, then we have in, it's for input, then we have high underscore lim, it's for high limit, low underscore lim is for low limit, then we have bipolar, we have ENO, enable out, we have red underscore val, which is a return value. We also have terminal out, is for the output or result. So we're going to write a program using this terminal to read the analog input from the temperature sensor and then scaling that analog input values into temperature unit, which is in terms of 50 degree Fahrenheit to 400 degree Fahrenheit. So in the other word, high limit is 400 degree Fahrenheit and the low limit is 50 degree Fahrenheit. The terminal in input is for analog input, which is the temperature sensor. Take a look on the bipolar terminal. For the bipolar terminal, we can set either value 0 or value 1. If we set value 0, it means it is unipolar. What does it mean by unipolar? So unipolar means it will only supply a positive voltage. In the other word, the unipolar setting is only meant for values between 0 to 27,648. If this terminal is set as 1 or is set as high, so the scale function will read the analog input as bipolar. Okay, the bipolar means the analog input will be rescaled in terms of negative 27,648 to the positive side of 27,648. So now we are ready to configure the scale function FC105. The analog input sensor is wired to analog input byte 256. The high limit will be 400 degree Fahrenheit, low limit will be 50 degree Fahrenheit. We're going to use unipolar, so we're going to set the bipolar terminal as low, which is 0, and we're going to set the output pin to the double word marker, which is MD20. So take a look on the PLC tech table. So we have a temperature sensor, which is the analog input. It is attached to address word 256. So this is IW, input word 256. Then we have unipolar. Okay, we use the memory 10.0. As the 10.0 is set as 0, which is low, so it becomes unipolar. We also have the temperature value as the output. Okay, the temperature value of the output, this one. And this MD is stand for memory double word. Okay, memory double word, address 20. So now we are ready to simulate our programming. So this simulation environment simulate a situation where a temperature sensor, which is the analog input, reading a temperature value of the oven. So now the temperature sensor is reading analog input as 0. Okay, when it is 0, so the system will read at the 50 degree Fahrenheit. If we look on the example, if we look on our example figure, the maximum value for the temperature sensor is 4095. Okay, using FC105 scaling function, the value 4095 is scaled to 27,648, meaning to say, if the temperature sensor read 27,648, this value will go to the maximum temperature. So now I try to manipulate the temperature sensor using a slider. So now the value is 1975. So with 1975, the temperature value is 75 degree Fahrenheit. So if we go to maximum, which is 27,648, so it will read as 400 degree Fahrenheit. We can see the changes of the temperature value is happen on the ladder as well as on the PLC sim. Okay, thank you.